All right, so my 25 to the 1/2, that's the exact same as the square root of 25, which I think you guys have done the square root of 25 before. What is that?
5.
5, okay. And then if my 1/2 exponent was a square root, my 1/3 exponent is a cube root. I'm doing the cube root of -27. Now, if they did not write, like right here, they didn't put a 2, they don't need to. If they don't put what kind of root it is, we are going to assume it is a square root. All right, but I'm going to look at number 5 here, the cube root of -27. What can I multiply 3 of? 3 the same thing and get a -27. Which one? What do you guys think here? I need 3 of the same thing that multiply together.
Is it like the 1/2, 1/3 thing?
1/2 was a square root. Yeah, exponent of 1/2 is a square root. Exponent of 1/3 is a cube root. If I have an exponent of 1/10, it's like a 10th root. All right, and what were you telling me, Evan?
-3.
Oh, not a positive, but a -3 in this case?
27 is negative.
That's true. Negative times negative times negative, 3 of the negatives ends up with a negative, with a -27. So that is true, -3. All right. And then I do want, yeah, which question?
So would we end up with an I since the negative is equal to
Oh, I was just going to talk about that. You read my mind. Okay, so here's how I can tell if I get an I, an imaginary number. The definition of an imaginary number of I is the square root of -1. Pretty much whenever I have an even denominator, in this case, like on number 6, it's 1/2, it's a square root. Whenever I have some even root, then that could give me an imaginary. So it could have I, the imaginary number. But this one right here, I had a negative root. Oh, sorry, I didn't mean that. I had a negative in my cube root. That's what I was going for. So I was talking even or odd. This one is an odd. It's a cubed root, like a root of 3. Sorry, even or odd, that's what I was going for. And an odd root doesn't have an imaginary. Cannot have I. All right, so that means we're looking at number 6 here now. That one is an even root. It's a square root, even number there. It will have an imaginary because it's an even root of a negative. That's the indicator right there. It's a little negative. So I'm going to treat it as, I mean, it's 1/2, so I'll treat it as a square root, but I'm going to treat it as a square root of a -1 and a square root of a positive 16. -1 times 16 is this -16 here. I'm just going to take their individual square roots here. Square root of -1, that's defined as the imaginary number. So there's the I. Square root of 16 is 4, so I'm just going to, I usually write the number first, 4i. All right. So that one had an imaginary. Number 5 did not have an imaginary. Any questions? My imaginaries. All right, there's one more detail I want to point out. I need to figure out if I will have a plus or minus or not. This one is like an even root, it's a square root. They don't write the little 2 right here because it's the most common, but it is a square root, it's got an even. And whenever I have that even, I will have a plus or minus. This odd number though, I've got a cube root, that does not have a plus or minus. That's just straight up 2 right there. All right, so number 3, this 4th root, 4 is an even number. because of that even root, I need the plus or minus. You guys should probably pay attention to this because especially on your homework, I think they usually give you like different boxes to fill in, right? So I would have to have a +2 and a -2 in the boxes.
So for number 6 has positive, negative 4i.
Number 6, yes, this is an even. So yes, positive or negative 4i. Yeah. So again, I'm gonna put this in purple. I don't have it in green, but yes, if they didn't write the root, it's because it's a square root and 2 is even. What about 4 and 5? Any of these guys evens with a plus or minus?
The 5 is.
5 is. This is an even root. I think number 5 had a cube root, not an even. 3 is odd, right?
And then number 4, the answer 5.
Oh, okay. So this one was a square root, which again, they didn't write the little 2 here. You don't have to. If you don't write it at all, it's assumed to be a square root. But it is even, which means that I will have a plus or minus. All right, how are we doing at home, you guys? All right. Okay, good, good. Thanks, guys. All right, I'm going to move on to the next section. Then we're going to find the indicated real nth roots. Real as in not imaginary. Okay, if for some reason I have to do, this is what we talked about up here. If I have to take an even root of a negative number, then I would have some imaginary, and it's not going to go in my list of answers here. I want all reals, not imaginaries. All right, so in this case, I've got n is 3. They want the nth root, and my n is a 3, so I've got a cube root of a, and my a is negative 216, so a cube root of negative 216. All right, so I'm trying to figure out what multiplied by itself. What can I have 3 of, all multiplied together? Gives me a negative 216. Let's see. I think it has to be bigger than 5. Keep it going. Wait, is it straight up 6? Is it?
Yeah.
Turned out to be a 6. So this is 6 like that?
Negative.
Oh, I was off by negative. Yep. I did have to have a negative 6, and I don't get a plus or minus because this is an odd root. It's a cube root. I have straight up negative 6. Yeah, question.
It wouldn't be real number because of the negative inside, right?
Because of the negative under an odd root, there's going to be no imaginary numbers. Only if I have a negative under an even root. Exactly. All right, so this one though, this n is a 4. I have a 4th root of 81. So here's that even root that we were talking about. If I have an even root, it could give me an imaginary number. Do I have an imaginary number on this one? I do?
Well, no, it's not a negative.
Oh, it's not a negative. It's a 4th root of a positive 81. So I don't have an imaginary. Good, because I needed all reals. I didn't want an imaginary. And then I know that let's see, I know my square root of 81 is 9. And then I'll take the square root of 9 to be a 3. It's like I did 2 different square roots. Like if you square twice, you get a power of 4. So 2 different square roots gave me a 4th root, same deal. So we ended up with a 3. There's no imaginary. Here's my second question to myself. Is there a plus or minus? There is a plus or minus? How'd you know that?
Because it's even.
Oh, even root gives me the plus or minus. Okay. So again, online, you're probably going to have to list it as a positive 3 and then a negative 3 separately like that. Probably can't just use the plus or minus sign, but it's the same idea. Ended up with 2 separate answers. But I keep asking myself those questions. Do I have any imaginaries? Do I have a plus or minus? Let's try this one. My n is 2 in this case, so I have a square root. Do I really need to put that 2 right there though? No, if I don't have the 2, it's definitely a square root of, and this is negative 49. Okay, so I'm gonna ask myself those 2 questions again. Do I have an imaginary in this case?
Yes.
How do you know?
One is even.
Oh, this is, yeah, the n is an even number of a negative. Even root of a negative, I'm gonna have to have an imaginary. So let's see, I'm gonna treat this as, an imaginary number is a square root of negative 1. So I'll treat it like that times the square root of a positive 49. Negative 1 times 49, there's your negative 49. We just separated it so that we would get the I, and then square root of 49 is 7, so we've got like a 7i. Okay, so I usually ask myself about the imaginaries, and then I ask myself about the plus or minus. Do I get a plus or minus on this one? What do you think, Abigail? Plus or minus? You do? How'd you know that? Nice, it's an even root, like the n is an even number. Even root, you get a plus or minus, so I have a plus or minus 7i. Now, this instructions here said to find the indicated real nth roots. I got some imaginary roots, but I don't actually have any real roots. So when they ask you to fill it in, I have nothing that I would have as the solution on this one. I don't know if they make you put like no solution or if they have you leave it blank or whatever. Just read their instructions, but yeah, I have no answer, no solution. Okay, any questions on these guys before I move on? All right, Samantha, so no solution because, I'm gonna read the instructions again. The instructions said to find the indicated real nth root. My roots that I found were imaginaries. They wanted the real root though. So that's why I said there was no solution, no real nth root. All right, anything else? All right, we're gonna look at these exponent rules. I do think you guys have seen this before. It's been a while though. So let's brush up on these. Whenever you have a negative exponent, it basically does the reciprocal. It flips your fraction. So like if I had, I don't know, 2/3 to a -1, it would do the reciprocal. It'd have a 3/2 to a +1. Now, this a to a negative exponent, it's like a over 1. If they ever have a whole number to a negative exponent, I would treat it as the fraction where it's over 1, and then I could do the reciprocal. That's where we got our 1 over a to the m. All right, and then we're gonna look at if you are adding your exponents. You can break it into 2 pieces, and you multiply a to the m times a to the n. You multiply those 2 pieces together. Now, the exact opposite, if I have exponents subtracted, I don't multiply, but I divide those separate terms together. Now, I do want to clarify. With addition and multiplication, order doesn't matter. Like if I swapped these, if I put a to the n first times a to the m, those are equal. That's fine. It's the same thing. But subtraction and division, order does matter. This does not equal the same thing as a to the n over a to the m. If I swapped the numerator and denominator, that does not equal what I started with. So we need to be very clear when order matters and when it does not. Multiplication, does order matter with multiplication? No? Give me an example.
5 times 5.
Try to pick 2 different numbers.
Okay. 5 times 7.
5 times 7, 35.
7 times 5.
7 times 5, also 35. Nice. So great example. order does not matter on multiplication, which is why I could have a to the n, I could have the n in the parentheses out to the m, or a to the m in the parentheses, and then it's all raised to the n. You could swap those and it's just fine. All right. Division, does order matter for division? It does? So like 1/2, 2/1, those are not the same thing? Okay, so order does matter. What I'm dividing by for division, in this case, I'm dividing by an n, so I need an nth root. Notice that what else they said it's equal to? This was not an m root. I didn't get to do that. It had to be an nth root. Whether I did the nth root first and then raise it to a power of m, or vice versa, if I do the exponent of m and then I do an nth root, that's fine, but it does have to be an nth root. I don't get to swap which root I'm doing. Okay, so let's go ahead and use those rules on these guys. We're going to simplify or evaluate, I guess. So I'm going to do, this is a denominator of 2. It's like a square root. I don't really need to write square root like that. I'm going to get rid of that too. There's my square root of my 4 and then all cubed. Okay. So square root of 4 is 2. 2 cubed. All right. 2 cubed is 8. All right, and I'm going to ask myself the same questions, you guys. I'm going to ask myself the same questions every time. Do I need an imaginary? Do I need an I?
No.
How come?
No negative.
Oh, this is the square root of a positive number? Okay, so no I. Do I need a plus or minus? How do you know?
I guess because
Because what?
the
Square root.
yeah, the root is still even.
Yeah, it starts out even and the exponent is multiplied by is off.
Yes, okay.
I won't get rid of it in time.
Exactly. An even gives me like a plus or minus. And if I have a positive cube, it stays positive. If I have a negative cube, it stays negative. I get both a positive and a negative 8. Okay. All right, so I did have a plus or minus on that one. No imaginaries though. Let's check out the next one. This is, it's basically what I'm talking about on this bullet point. I said the denominator is telling you about which root you're going on. I have a denominator of 3, so we're talking about a cube root of 8, and then it's all to the 2. So I basically just applied this rule that we saw. Cube root of 8. What is my cube root of 8?
2.
2, straight up 2? Squared, 2 squared is 4. Okay. Did I get an imaginary, first of all?
No,
No, there was no negative, no imaginary. Do I have a plus or minus?
no.
Oh, so this, what I had in purple, it had to do with the fact that I had an even root. This 3 is an odd root, so you're right, I do not have a plus or minus. It's just straight up 4, positive 4 in this case. The other one was a positive and negative 8. All right, you guys take a sec, do number 12. Ask yourself those same 2 questions. Do I have an imaginary? Do I have a plus or minus? So you guys take a second, answer number 12. All right, Tabitha, what'd you get? All right, you got a 4, like a straight up 4. Positive. Okay, did you get a positive and a negative? Straight up 4. Positive 4, no negative 4. Okay, so that is true. My cube root of a negative 8 is all squared. Anything squared should be a positive number. So I just came up with a positive 4. It also was, if I break this down here, cube root of negative 8 is a negative 2. It's like I had a negative 2 squared for a positive 4. Both of those ended up with a positive 4. Okay, any questions? For real? I don't have any questions. All right, then let's have you guys pretty much do this with your calculator. Some of these do not turn out so pretty. So we are going to talk about what buttons I have to push. I have to do 9, and then there's this little arrow looking thing, like it's raised to the, and I need it raised to the 1/5. If you put it like this, 1/5, if you do it like that in your calculator, you're not going to get the correct answer.
You have to put the 1/5 in parentheses.
Yes, I need to raise it to this entire 1/5 exponent. So put parentheses around this. Raise it to the entire 1/5. And we'll see what you got. So actually try doing each of these. I'm just going to start calling on names here. So Alani, give me number 13 whenever you put it in your calculator. Destiny, can you give me number 14 whenever you put that in your calculator? And Sadie, give me number 15 whenever you put that in yours. Now it does say round to the nearest 100th. How many zeros in the number 100? 2 zeros? Okay, so this would mean 2 decimals. All right, so you guys just type it in once you get it. I know you guys are online, so nice, Lenny. You got, this one was a 1.55. Is that what everybody else got? Yeah? You guys over here, did you guys get this? Lauren, did you get it in your calculator? Yeah, got it, nice. All right, so Destiny, you got the next one. Nice, this is number 14. It looks like you got a 2.54. Is this what everybody got? 2.54. Okay. I want to make sure we know how to use our calculators. Last one, Sadie, you got the last one here. This is the 4th root of 7 and then all cubed. Oops. Come on. Sadie, you there? All right, go ahead and put this in your calculator, see what you get. All right, so you got a 4.3. Is this what we all got?
Yeah.
4.3 is, so if you go to 2 decimals, it was what, like a 4.30 or something? Sadie, you there? Because they said to round to the nearest 100th, 2 decimals. Is your next decimal, did you not write it because it's a 0? Yeah, 4.3, okay. Good sign, good sign. All right, you guys have questions on this calculator stuff? Good. All right, we're gonna step it up a notch then. These guys right here, these are all straight up numbers. We're gonna put some variables in it. So 16, 17, 18. You're gonna simplify this with only positive exponents, no negative exponents. Okay, so number 16 here, I'm gonna start using my rules. One of my rules about exponent raised to another exponent was that I would multiply those exponents together. So I'm gonna have like -2 times 3 is a -6, but I'm supposed to have only positive exponents. So I'm going to do the reciprocal. I'm gonna do 1 over x to the positive 6 now. Okay, it's in the denominator, which is not my favorite, but it does have a positive exponent, so it's considered simplified. All right, so this rule right here, I'm gonna look at my list of rules. It looks like I'm dividing these. So that puts me like this. As far as, it wasn't the exponents that were divided, it was the entire base to an exponent that they were all divided. So I'm going to simplify it down by subtracting my exponents. All right, so order matters with division and subtraction. I have to do the exponent in the numerator minus the exponent in the denominator. I have to do a 2 minus 5. You don't get to choose which order you put them in. Which 2 minus 5 is a -3, but I'm supposed to have positive exponents, not negatives.
Put it beneath 1.
So like this, 1 over y to the -3 like that.
Not being negative positive.
Oh, 1 over y to the +3. That was kind of the whole reason we were doing it, because we didn't want the negative exponents. So there we go. There's our final answer. Okay, and then last one in this section at least, z to the -5. I got to deal with that negative exponent. Negative exponent, I'm going to do basically what you guys just did with this y to the -3. You put 1 over your y to the +3. I'm going to put this 1 over z to the +5. And then there's still this other z there. It's still multiplied by that plain z. So Crystal, what is the exponent on this z when they didn't write it? So they didn't write one, but I could write an exponent that means the same thing. So an exponent tells me how many of the same are multiplied together. So like if I have a plain z, how many of them are multiplied together? Yeah, there's just one of those z's there. Perfect. Okay, so let's, plain z is like z to the first. The reason I was asking about the exponent is because my rule for the multiplying, I had to add their exponents. So that's why I wanted to know what the other exponent was. I will now add my 5 plus 1. So I get z to the 6th. It's a +6, so we are good. Okay, questions on this stuff? No? Have you guys done this before? Does this look somewhat familiar?
This was familiar.
Okay, it's probably been a while, but
Around this last.
okay. Yeah, probably been a while, but it looks like you guys have seen it. I'm going to step it up a notch. We're going to solve an equation now. So I'm going to divide by 4 on both sides. Got the x to the 5th alone, good. Equals 32. But now I need x. I need to get rid of that like 5th exponent. What's the opposite of raising something to the 5th? Yeah, what is it? A square root like this? Oh, square root to the 5th. Oh, okay. So you mean a 5th root? All right, there you go. 5th root, opposite of a 5th exponent. There we go. Which my 5th root, 5th exponent, those are opposites, so they kind of got rid of each other. I just have an x left. I do need to know what the 5th root of 32 is, though. What number can I have 5 of them all multiplied together and get? You guys, oh, you guys all went with 2?
Yeah.
All right. I had 5 of those guys. There's a 2 times 2 is 4, another 4, and then you've got that other 2 there. 4 times 4 is 16 times 2 is 32. That works. That was a 2. The nice thing about these, oh my gosh, I hope you guys do this. You can sub that in for the x, and you can totally check your answer and make sure you got it right. When it comes to tests, that's like a huge advantage for you to be able to check your answer. So maybe get in the habit of that. I can put just in my calculator, I can do 4 times 2 to the 5th and see if it actually equals 128 or not. Yeah, it's a real quick way to answer. Check your answers. Yeah, there are other types of problems that it's not quite as easy. These ones, like I'm saying, take advantage because this is a nice way to make sure you're on track. Now, I do want to point out on this one, do I get rid of my exponent or the subtraction first? Which one do I get rid of first? I know I got to get rid of all of it, but which one do I start with? That's true. How do you know to start with that though? I can't just add 3 on both sides. I can't do that. Oh, I would have to be, yeah, it'd be like having x minus, it'd be like having that whole thing with a +3 on the outside. It's not that helpful. I needed it to be, all together there. So for that reason, yeah, I'm going to do a 4th root on both sides. That whole side, this whole thing was all to the 4th. And then I did that whole side all to the 4th root. So yeah, they do actually get rid of each other pretty quick there. 4th root of 21. Okay, that is not pretty, first of all. But then I need to add 3 on both sides. All right, I'm gonna do something wrong. You guys tell me what I do wrong.
You got the 3. Well, you can't add it to the.
It's 24. The 3 goes outside of the grid.
So this 3 is not under the 4th root, but this 21 is under the 4th root.
Right, okay.
So I have to leave them separate like this. Okay. Now, I didn't ask myself this question on the last problem, but I should have. Do I need an imaginary number?
No.
No. What about 19? Do I need an imaginary number on that one?
No.
No, I don't need an imaginary number on either one. I was taking a root of a positive on both of them, so no imaginaries. What about plus or minus? Did I need a plus or minus on this one?
Yes. No.
Well, I heard yeses and nos. Which is it?
No. You don't need it on that one. You do need it on the next problem.
Oh, this was a 5th root. 5th root is odd, so I did not need a plus or minus. This one, you guys said yes.
Yeah, if you wanted to find that, you could round what the root was, and then you need a positive and negative.
I do need a positive and negative. Whenever I have an even root, this was a 4th root, 4 is an even number, I go with my plus or minus, which means I actually have 2 separate answers here. I've got a positive 4th root of 21 and then plus 3. I've got a negative 4th root of 21 and then plus 3. So I think online, I think they have you guys enter it in 2 separate answers like that you can't really use the plus or minus button. Yeah. The hobby round it, okay. If they tell you to round, go ahead and get the decimal. If they don't tell you to round, they probably don't want you to round it. You probably have to leave it like this if they didn't tell you to round. All right, and then 21 here. I'm gonna do, like I said before, I'm gonna do what's on the outside first. So I'm gonna divide by -2 first. So it looks like I get a positive 64. Now I need my cube roots to get rid of my cubed exponents. All right, what's cube root of 64 again? Oh, we already did that one. Yeah, that was a 4. Now, do I need a plus or minus on this one?
No.
No?
2 separate answers.
Okay. It's a positive, or sorry, not a positive. It's an odd root, so I don't need a plus or minus. Do I need an imaginary?
No.
No, again, it's an odd. In fact, it was an odd of a positive, so that's for sure going to be straight up 4. And I will subtract 1 on both sides.
And straight up 3.
Yep, just that single number 3. And I love that you guys can just check it. You could put it in there and see if -2 times 3 plus 1 to the 3rd, does it actually equal a -21 or not? That's like the best thing ever. You can just check and make sure. All right, so just to clarify here, we have more than one real solution. Like this one had 2 solutions. I have more than one real solution when I had an even root. It's got to be even to give me a plus or minus, which gives me more than one. Well, even if it was an even root of a negative, I still have a plus or minus. They're both imaginaries, but I still have a plus or minus, meaning I have more than one of this. Oh, I get what you're saying.
Positive and negative.
So if it was an imaginary, so I get what you're saying, even root of a positive, meaning the even takes care of the whole more than one part, and then the positive takes care of the fact that it's a real solution. There we go. I got what you're saying. Okay. Do you guys need any clarification on this kind of stuff?